Okay, what up YouTube? In this video, I'm gonna go and try to dial in my tolerances on my CNC machine. I made a video previously about the process I go from going to Fusion 360 to actually machining carbon fiber on my CNC machine. And I do this to make my own drone frame. And I thought I had my hole tolerances down. So I went to machine two sets of frames, Questor frames. And in that process, I realized that my hole tolerances are not dialed down. Now, thankfully, those cuts weren't at a total loss because the holes ended up being too small. So I just bought a 3mm bit and I drilled the holes out with a 3mm bit. But I would like to actually know what I'm doing as far as setting up hole tolerances on the CNC machine. Now, my mentor, I guess you can say, where I get my most information out from CNC machining is Pat Regan. He has a blog, Pat's Head, and he also has a Discord server, and you can pretty much just message in that Discord server and get some feedback. And he's the one who really, his blog posts and emailing them and talking on Discord kind of got me off the ground of machining with carbon fiber. So in the Discord, I mentioned that my hole tolerances are off. And he mentioned that it's probably because the bit actually gets worn down because carbon fiber is real hard on the bits. But, he recommends that you don't buy expensive bits, you buy cheap bits, which is what I do. But he recommends always changing the bit out on a new job. And then that's probably why I had hole variances, because I was cutting a ton of arms and stuff with those bits. So one of the things I want to try to find out today is how many holes can I drill on a bit and still expect to have consistent hole tolerances. Another thing I'm trying to figure out today is what should I make the hole tolerances on Fusion 360 so I can pass screws through it. Now, the project that I'm going to cut today is a Cinewhoop frame project that I've been working on, and I want to cut the main body for it today. And the interesting part about that project is not only am I using M3 screws, but I'm also drilling holes for M2 screws. So I do have two sets of bits. I have a 2mm bit that I'm going to use to drill M3 holes, and I have a 1.5mm bit used to drill M2 holes. So I'm going to have to do this process over twice to learn about both bits, to try to understand my tolerances on both bits. And the way I decided to do this is I'm going to start out with the 2mm bit drilling M3 holes. I have a file that has 7 holes in it. The left hole is a 3mm hole, and the right hole is 3.3mm hole, and it steps up 0.05 millimeters. So it's 3mm, 3.05, 3.1mm, 3.15, and so on to get, and that's 7 holes. So what I'm going to do is I have this 3mm, I already have 3mm carbon fiber set up in the jig from the previous project, and my main frame is going to be 3mm carbon fiber. So I'm going to run that project, which is 7 holes, and then I'm going to run the project a second time, so I'm going to have 14 holes. And I'm going to use that to determine, the first set's going to determine what size hole clearance I should have for a M3 screw. And then doing it again, I'm just going to see if the hole tolerances drift between those two. So let's go ahead and I'm going to use a new bit, and I'm going to keep track of how many holes I drill on this bit. And then when I go to cut the main frame, I'm probably going to use the same bit and because I highly doubt that 14 holes is going to wear the bit down. I think what probably wears the bit down is not drilling holes, but when you're actually doing the contour, which when I cut the main frame, I'll drill the holes first and then I'll do the contour cut second. So let's go ahead and run this program and see what our first set of holes look like. Okay, here we go. 14 holes. The left holes are 3mm. The right holes are 3.3mm, and it's in 0.05 increments in between. The first hole, this bottom left-hand corner is the first hole, and this top right-hand corner is the second hole. So I have a brand new M3 screw. It doesn't fit in the first hole, doesn't fit in the second hole, doesn't fit in the third hole. Okay, it fits in the fourth hole. Fits in the fifth hole, sixth hole, seventh hole. I would say though, even though it fits in the fourth hole, it's kind of tight. I would say though, I think the fifth hole would be a good happy medium. The fifth or sixth hole. Okay, and then on the second round, kind of doesn't. So in here it fits in the fourth hole. In here it doesn't fit in the fourth hole. But man, that's definitely tighter. So that is true that the bit wears down really fast. 3.3. Based off the second round, the sixth hole seems like it's the best. So it almost makes you want to say to... That's something how the bits wear down that fast. That gives me more questions than answers because I don't think 14 holes are that many holes. That almost... So either 3.25 or 3.3. I almost say make all the holes 3. So 3.3. Like according to this test, I would say make all the holes 3.3. So when I set up the project, I'll make all the holes 3.3, and I'm still going to use the same bit. So now I'm going to do the whole thing all over again, but I'm going to switch the bit out to 1.5 millimeter bit and drill M2 holes. Okay, so same thing with the 1.5 millimeter bit, and the fourth hole seems to be a good happy medium for tolerance. 1, 2, 3, 4, and I'll tell you, 1, 2, 3, 4. The tolerances seem the same. Makes me wonder if I should go and drill all my holes out, even the M3 holes, with the 1.5 millimeter bit. So, okay, what is that? 2.05, 0.1. So that's 2.15 for the M2 holes. I'm thinking about going and drilling a M3 hole with this bit and seeing what the tolerance is, and maybe just do all my hole bits with this 1.5 millimeter. Okay, so I drilled 5 more holes. First, I drilled 2.15, and they're both good. So definitely we got that locked down for the 2 millimeter holes, 2.15. For the 3 millimeter holes, I drilled 2 3.2 and 1 3.25. The 3.25 holes seem consistent. Well, actually, no, this is 3.2. They seem consistent. They are a little tight. So I'm probably going to do the project with a 1.5 millimeter bit, using the M2 holes being 2.15 and the M3 holes being 3.25. So that's what I'm going to do. We'll run the project and see how well it works out. Okay, so I really messed up. And I should have known this was going to happen. I had plenty of warning that this was going to happen, but I wasn't paying attention. But basically, in Fusion 360, when you select a contour, 2D contour, it can contour on the wrong side of the line, even though it shouldn't, because in Fusion 360, you have the 3D object in the manufacturer. So it should know that that's what you want. You want that 3D object. I've never had this problem before in all the other CNC projects I've done, but now it's a lesson learned. So you had to pay attention to what side of the line is contouring when you do a 2D contour. And then I couldn't figure out how to flip it. You flip it by these little red arrows. You just click on the red arrow and it'll flip it to the other side of the line. Now, this is entirely my fault, because if I would have been paid attention to the manufacturer page, if I would have zoomed in more, you see, what I did is after I did the 2D contour, I did a simulate to make sure everything was going to be good. And I didn't zoom in enough to see that it was actually cutting on the wrong side of the line. So as you can see, it nearly cut off these holes. Now, the interesting part is I probably could use this frame, but you see how the holes are so tight? But I guess it's a lesson learned. But for the scope of this video, I got the whole frame cut out so we can inspect the holes and see if my hole tolerances were good. So let me remove the frame from this board and we'll see what it looks like. Okay, here's the piece. I'm probably not going to use this. I'm probably just going to take the loss and cut out another one. But like I said, it's a good test to see how our hole tolerances are. Oh, so you see that's a little tight. They fit, but they're a little tight. I wonder if there's any of them that are... See, these are tight. And that's something. All of them are tight. You see, these are ladder ones. Isn't that crazy how that bit gets worn down? I can't even fit it in these. Isn't that crazy? We'll have 4 more for the stack. Yes, I need to increase that anyway. Okay, for the M3. M3's fine. M3 is fine, maybe a little tight. M3 is fine. The M3 holds a little better. They are still a little tight. You see, that one's perfect right here. But if we go to this one, it's still tight. So I wonder if I should just make all the holes 0.3 millimeters bigger to begin with. Well, oh, let me check these. See, this one's perfect. And this one's tight. So, like I said, I got to cut this again. Maybe I'll start making all my holes 0.3 millimeters bigger, and we'll see how it goes. Okay, second time seems to be the charm. So I cut all my holes with the 1.5 millimeter bit, and I set all my hole sizes to 0.3 millimeters bigger than what the screw size is. So the M2 holes were 2.3 millimeters, M3 holes were 3.3 millimeters. I started the Fusion project over from scratch, and it automatically selected the right side of the contour for the cutting, which it should have done in the beginning. But now I guess it's a learning experience. Now I know to check that every single time. So I'm going to remove this. I'm going to sand it, clean it up, and then we'll check our hole tolerances. Okay, so I checked all the holes with M2 and M3, and all my tolerances were good. So the objective of this video turned out to be a success. I figured out how I should do my tolerances when I'm cutting CNC, and the secret is to cut all the holes with that 1.5 millimeter bit. I'll have Amazon link down in the description, and add a 0.3 millimeter tolerance to your hole cuts. It's a shame that I had to go through two different cuts. But that's entirely my fault. But even though that's a shame that I messed up the first one, my hole tolerances would have been off on the first one. So it's a good thing I did the second one.